Hey everyone, welcome back. In this video, I'm going to create my WebRTC client. I'll create a Kotlin class called WebRTC client, and it's going to be injectable, so I'll mark it as inject, and using constructor we will inject the context and also JSON. I'll create my main function called initialize WebRTC client, and as the argument I'll get the username type string and the observer of type observer, the peer connection observer. So inside it I'll store my username and also my observer like this. So this dot username is equal to username, and this dot observer is also equal to observer. So right after that I want to create my peer connection, which is going to be null initial. But to create my peer connection, first I do have to init my peer connection factory and also create my peer connection factory. So I'll create my private function init peer connection factory, and it will require an application. So we just have to call peer connection factory dot initialize, but as option let me create my options here, which is going to be peer connection factory initialize options, and use the builder class and set some property to it. Enable internal tracer to true and set field trials to WebRTC -H264 high profile /enabled/ and then create initialize options and pass it here. But first thing inside this class is to init this peer connection factor. So let me switch this to context because it's requiring context. Okay, so first thing we have to init our peer connection, and then we have to create our peer connection factory. So let me create the function create peer connection factory, and it will return a peer connection factory. So I'll return the peer connection factory.builder class and set some property to it. First, video decoder factory, and it wants a video decoder factory, which I'll create a default video decoder factory. And as the context, let me create my context up here, private val EGL base context. It's going to be EGL base dot create and get EGL base context. So I'll pass the EGL base context and set video encoder to default video encoder factory also, and give the EGL base context true for enabling VP8 encoder, and also true to enable high profile. And also I'll set some option for it. I'll use peer connection factory options, create a new instance of it, and apply some variables to it. Disable encryption to false, and also disable network monitor, and then create peer connection factory. And right after here, I want to create a peer connection factory object, and using lazy delegation to create an object of it. Create peer connection factory. And after that, it's time to create a function to create peer connection finally, and it will return a peer connection object. So I'll return peer connection factory object and create peer connection. So here we are going to use the iServer and the observer. So let me create my iServer object here. It's going to be private val iServer. It is a list of peer connection iServer, and as a URI, username and password, I'll pass this. So keep this in mind. You have to use a TCP turn server because in some networks UDP packets are blocked by cellular networks. So you have to use a turn server that supports TCP packets in case you want to use your application using cellular network. So let's pass this iServer as the first variable to my peer connection, and as the next one I'll just pass the observer to it, which I'll receive here from my function. And I do have to mark it as nullable, so we are good to go. But right here I want to initialize my peer connection using create peer connection and pass this observer to it. Okay, so after preparing our peer connection, it's time to create a way to connect two peer to each other. So to do that, I'll create a function named call, and it will get a target of type string. And using my peer connection, I'll create an offer, and for the STP observer, I'll just create my own STP observer. My STP observer, I'll explain in a second. It's going to be an open class STP observer. Since I'm not using all of these methods, I just want to override my onCreate success and onSet success in some situations. So I'll create an open class to extend this anonymously. And also I'll create an peer connection observer. My peer observer also is going to be open class, and it extends from peer connection observer. I'll implement all of its methods, and we are ready to use these two classes. So right here as the observer, I'll just pass an anonymous class of type my STP observer, and for the constraints I'll create a global variable of it, private val media constraint is equal to media constraints, and apply, and I'll add some mandatory to it, media constraints key value pair, and it's going to be offer to receive video, and the value is going to be true, and pass it inside here. And right here I'll override onCreate success method and rename this to description. Let's go back to my peer connection observer and rename this to desk, just like that. And right here I want to check if this offer is created successfully first I want to add it on my peer connection. So using peer connection, I'll use set local description. Now create another anonymous object of my STP observer, because I'm just using on set success method, and as the STP desk. So I'll create my offer first. After generating a session description, I want to add this on my peer connection first and send this to the other peer as their remote description. But to send this using WebSocket, I'll have to create an interface. Let's call it listener. It's going to have a function on transfer event to socket, and it's going to get a data model, data model. So right here, after setting this session description to my peer connection, it's ready to send to other guy. So using this listener that I haven't created it here, I'll use it var listener of type listener. It's going to be null initially unless some other class set this listener for me. So right here, I'll check if it's not null. I want to transfer some data to WebSocket. So I'll create a data model. The type of it is going to be data model type dot offer. The username is going to be username that is being derived from initialize function here, and the target is going to be target coming from this string, and the data is going to be description from this session description. So after sending this to WebSocket, the target will receive our offer. I'll create the answer function as well. It's going to be pretty much the same as the call. So using peer connection, I'll create an answer this time, and as the observer, I'll create an anonymous class of my STP observer and pass the media construct to it. So I'll overwrite the onCreate success and set this as the local description. Since we are the other guy that we are generating the answer, it is still our local description, so we want to set this local description. And for the observer, again, we create an anonymous class, my STP observer, because we need the onset success. So as the STP, I'll just pass the description to it. And after we successfully set this as our local description, it's time to send this to the other guy. So using listener on transfer data, we will create a data model of type answer, and the username is going to be username. The target is target that is derived from my function, and the data is going to be description of this session description. Okay, this video is already too long. We will continue on the next part.